Now for example number 3, we've got this diagram where they tell us that triangle DEF is similar to triangle MNP and we have to find the value of x. So one of the first things that I want to do is set up a proportion. Now when I go to set up a proportion, I'm going to look at this side right here, DE and MN. So that's going to be one side that I'm going to take a look at, and then the other side that we'll look at will be the NP side, because that's going to be the same location as the EF side. So I'm going to set up a proportion using those 4 segments, and your proportion is going to look like this. So when you set up your proportion, make sure the first thing that you do is write down the segment lengths. Don't just jump right into the second step where you're substituting in your numbers and your variables. Make sure that you write out the first step, because that's what's really going to help you kind of see where things are and how they're lined up. In this particular example, it's a little bit easier to see visually because the triangles are set up in the same orientation. But if they weren't, it's going to be a little bit easier for you to set up the correct proportion if you highlight the pieces that are similar and you also set up your ratio, writing the letters that represent the segment lengths. So once you've got this piece set up, I'm going to go ahead and solve it by using a cross multiply and divide. There's another way that you could solve it, but I'll just do it using cross multiplication and division. So what I'm going to do first is multiply 12 and x together, and you know that's going to give you 12x. And then we'll have 9 times 20. So when we multiply those together, you'll end up with 12x equals 180. Now some people visually, you might need to write it out like the first step, 12x equals 9 times 20, or you might be able to do that mentally and just go right to the next step. In either case, make sure you have at least the second step shown. And then the last thing that you're going to do, when you divide both sides by 12, so 12 goes into 18 one time with 6 left over, and then 12 goes into 60 5 times. So you end up with an answer of x equals 15. Now let's reread the question and make sure that's all that we had to do. Find the value of x. Yep, that's it. We're done. Now here's my question though. What if? There's going to be 2 what ifs that I want to explore. The first one is if we take a look at that second step where we have 9 over 12 equals x over 20. If we would have reduced the 9 over 12 and rewritten that as 9 over 12 when you reduce that, because 3 goes into both terms, so 3 goes into 9 3 times and 3 goes into 12 4 times. If I were to use that fraction instead of 9 over 12, would I still get 15? So let's kind of explore that and see what happens, because maybe we do, maybe we don't. So let's kind of see what happens with that. So we'd have 3 over 4 equals x over 20. Now 4 times x, that gives us 4x. And then 3 times 20, that gives us 60. When we divide both sides by 4, we get x equals 15. So that's pretty cool. That would have worked out the same way. Not too bad. That's pretty wild. But here's another what if. What if instead of using DE and NM, say we use DF and MP? Would we get the same result then? So I don't know. Let's check that out, because one of the things that you want to be able to do is make sure that you have a really deep understanding of proportions. So we'll take a look at and we'll play the what if game. What if we set up this? What if we set up that? Because sometimes there's more than one way to solve a particular problem, and to really understand it, you want to be well versed in as many ways of solving a problem as possible. So let's go ahead and set up that proportion and solve that and see if we end up with the same result of x equals 15. So check it out. When we set up our proportion, again, don't be lazy. Make sure you write the correct letters first to set up your proportion, substitute in, and then take your time, solve for x. And when you do that, you'll end up with x equals 15 again. Now, what if instead of 12 over 16, if we reduce that? So 12 over 16, let's just kind of play with that for a second. If we reduce that, 12 over 16, 4 goes into each one of those. So 4 goes into 12 3 times, and 4 goes into 16 4 times. Well, that's the same thing as what I had up above. So both of those would end, if I reduce a 12 over 16 to 3/4, I would still end up with getting x equals 15. And why is that the case? Because 3/4 is going to be the scale factor of triangle DEF to triangle MNP. Because if you have 2 triangles that are similar, corresponding sides are going to be proportional. So either way we slice or dice it, we end up with x equals 15. So you really do have your option in terms of how you want to set the problem up. Just take your time to make sure you do set up the proportion correctly using both side lengths and then substituting in the variables. Now let's take a look at example number 4. Now before we get into example number 4, we're going to have this equation here about perimeters of similar polygons. It's not really a theorem per se, but it is kind of a rule here in geometry. If you've got two shapes that are similar, then you can take their side lengths, add them up, and find their proportion of one of the figures to another figure, and that ratio, the ratio of their perimeters, is going to be equal to the ratio of any of the sides. So that first piece just means a ratio of perimeters. Each one of the other pieces that's there, that's going to be the ratio of each one of the pairs of corresponding side lengths. So if you know the perimeter, the ratio of the perimeters, you can use that to help you figure out any of the side lengths. Now remember, each one of the ratios of the side lengths, that's going to be equal to what thing again? Scale factor. So if you know the scale factor, you can find out either any of the side lengths or even the ratio of the perimeters. So that's a pretty cool thing, and we're going to use that here in example number 4. Now in this diagram, we've got these two figures. They tell us that they're similar. Find the scale factor of FGH JK to ABCDE. So if we look at those two figures, we're going from the larger figure to the smaller figure, because remember, you want to take your time and make sure that you read correctly for that. So I can pick any of the two sides that I want that are corresponding, and I'm going to pick FG to AB. So I'm going to work with those two sides. Now FG has a length of 15 and AB has a length of 10. So when I reduce that, I end up with a ratio of 3/2. So that's my scale factor for the larger figure to the smaller figure. Now when I go to find the value of x, again, you're going to have a lot of different options in terms of how you want to work with that. But when we go to do that, you'll set up your proportion, and instead of actually using two of the sides, we could start out with the scale factor. So we're going to work with 3/2 since that's our scale factor, and we're going to set that equal to, now here's the thing, would it be x over 18 or 18 over x? And what you have to do is make sure that you set up the proportion correctly, because we're going from the larger figure to the smaller figure, so that would be 18 over x. Now cross multiply and divide and figure that out and see what you come up with for the value of x. Go ahead and hit pause and do that now. Then come back and see if you got it correct. How'd you do with that? Hopefully you came up with x equals 12. Did your arithmetic correctly? Not a big deal. Now for the last part, part C, find the perimeter of figure ABCDE. So what we're going to do first is we're going to write down the ratio of our perimeters, or our scale factor. And our scale factor was 3/2. So 3/2, that's your scale factor. That's going to be equivalent to the perimeter of our larger figure, which in this case is FGHJK, to the perimeter of the smaller figure ABCDE. That's going to leave me with this proportion here on my second line. Now here's a really quick way to add these up. If I take a look at 15 and 15, well, I know that part's going to give me 30. 12 plus 18 gives me another 30, so far I'm at 60, and then add 9, so I'm at 69. So 69 is what I get for the total of perimeter of F, G, H, J, and K. So that's going to give me that perimeter. Perimeter of A, B, C, D, E, I don't know what that is, so I'm just going to call that P for perimeter. Alright, I can't use X because I already used X up in, that's already given in our diagram, so we're going to let P stand for the perimeter. Now again, when we cross multiply and divide, you guys are good at this part by now, so go ahead and hit pause, then come back and see if you did your arithmetic correct, which I'm sure you will. So you should have come up with P equals 46. Now, don't get lazy. Go ahead and write a sentence to make sure that you answer that question. The perimeter of ABCDE is 46. So that's all there is to question number 4. It's a little bit of work, but you guys can easily do that. Alright, so that's the end of this section of 6.3 using similar polygons part 2. Be sure you tune in for part 3, which is the next video in the series. Thanks for watching. You guys have a great day. I'll see you soon. Peace.